How many permutations are there of the letters AAA? One. That's just like Canada, Canada, Canada. We only have one. So here's the math behind why. Given a set of n objects in which there are A of one kind, B of a second kind, and C of a third kind, then the number of distinguishable permutations is... What does distinguishable mean? You can tell the difference. So different permutations is n factorial on the top, so the amount of objects that we have, divided by the repetition. So an A factorial for the first kind, B factorial for the second kind, C factorial for the third kind. And that can be extended if you have more than 3 kinds of repetition or less. So the reason this turns out to be 1, on the top we have a 3 factorial because we have the 3 A's. But how many of them repeat? 3 repeat, so we're dividing by the 3 factorial, which gives us 1. That's why it is what it is. So example number 1 looks very similar to the questions we've already done. How many different 5-digit numbers can be made from 46164? Keywords.
Different 5 digits. 46164.
Grab my red pen. The only thing that's different today from what we did the rest of this part of the unit is now you want to always ask yourself, is there repetition? So I'm going to show you with the FCP and I'll show you with the formula, and you can pick or choose whatever one you want. FCP, we're going to start the same way we started before, so 5 blanks. How many choices for the first blank? Not a trick question. 5, and then, and then, and then, and then. And if I'm lazy and just don't want to write all that, I could just write. So we end up with a 5 factorial. Then I need to worry about the repetition. So what is repeating? So the 4, we need to do something with that, and we need to do something with the 6s. How many times does the 4 repeat? So we get a 2 factorial. How many times does the 6 repeat? 2 factorial. That's how you deal with repetition. You divide by the number of things that repeat. This would be a non-calc question because you've memorized all these factorials up to 5. 5 factorial. On the bottom, I have 2 factorial, which is times 2. BEDMAS says we do the bottom first. And then the division, 30. If you'd rather use the formula, we need to figure out what n and r are. So how many objects do we have and how many do we need to arrange? Not a trick question. How many objects do we have? 5. And how many of them do we need to arrange?
5.
All 5 of them. And then we're going to divide by the repetition exactly like on the other side. How do we figure out a 5p5 without our calculator? Yes. How?
The formula.
Yes. NPR equals?
N factorial.
Yes.
N minus r.
Yes. So we're going to have a 5 factorial on the top, a 5 minus 5 factorial on the bottom. BEDMAS says I have to do these brackets first, so the n minus r. And then I still have my 2 factorial, 2 factorial. What's 0 factorial? And this is the other reason it can't be 0, because here you'd be dividing by 0, which causes your paper to burst into flames. And if you look where we were on the other side and you look here, what do you notice? Exactly the same, has to be 30. Zero factorial is 1. So you can use the blanks, you can use the formula, whichever one you prefer. I'm a blank kind of girl. Number 2, how many permutations are there of the letters in the word Mississippi? Lots of repeat going on here. So we could write out 11 blanks, and then we could fill in 11, 10, 9, blah, 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 all the way to 1. But what's the easiest way to do that rather than doing all that? That's why the formula starts with that n factorial on the top. Okay, now what's repeating on the bottom? The S's, the P's, and the I's. How many times do the S's repeat? How many times does the P repeat? And the I? This would be a calc question, so grab your calc. Just remember you're going to have to bracket the bottom. Remind me how to get the factorial. Remind me how to get the factorial on the calculator. Yep, so the math button, tab 1 to the left, prop, which is PRB, pick number 4. Now save yourself some time on the bottom. Don't go through all those steps. That's why we memorized. Instead of putting 4 factorial, put the value. What is 4 factorial? It's 24, because that's going to be easier to type than going through all those steps. Times 2 times 24. Okay, save yourself some time. Offer. And let's list them all out.
What?
Just kidding. Questions so far? Number 3, read to read. On the test, no. On the exam, I would, just to make sure that they know what you know and that it's really crystal clear. What would you like me to highlight in number 3? Okay. Is there any restrictions in A? No, it's just a straight up. So count the number of digits that we need. Again, you could choose to write out 7 blanks and put 7, 6, 5, 4, 3, 2, 1 if that's the way your brain likes it. What's the repetition? Three factorial to represent the 2's, and a 2 factorial to represent the 3's.
Did you have to know 7 factorial?
Nope. And again, on the bottom, save yourself some time. Don't do all the factorials because it's too many buttons to press. Put in what the values are. Oh, I think just heard 2 different answers at the same time. 420. Confirm, no. That sounded confirmed and not confirmed all at the same time. Sure isn't really the confirmation I'm looking for. Agree? Is there restriction in part B? Okay, so here's a combination, restriction, and repetition. What I'm going to worry about is the restriction first. I'll worry about the repetition at the end. So let's use some logic and go through all the possibilities. So case number 1, can we start with a 2? No. Can we start with a 3? Okay, so let's do that. If we start with a 3, what's our choices for the second digit? Has to be 4 or 5. Does it matter what follows? Nope. Okay. Ooh, ooh, ooh. to be a 4 next?
No, if it's a 4, it doesn't matter because even if it's a 2, even if it's the lowest number, it's still.
Yeah, because the next one is 0, right? So it's not going to matter. Anything is going to be bigger if it's a 4. Okay, so how many 3s do we have? 2. How many 4 5s do we have? 2. Does it matter what comes after that? Okay, how many letters or numbers are left? 5 or factorial. I'm just going to pause there and go on to the cases, and I'll come back and simplify that up and worry about the repetition. Okay, so we couldn't start with a 2. We just did starting with a 3. Can we start with a 4? Okay. Does it matter what comes behind it? Could we start with a 5? Does it matter what follows after the 5? So we can smush these into one case if we wanted to. If you want to keep them as separate cases, that's fine as well. Could we combine the 3 and the 4 and the 5?
No.
Why can't I put these down all into one case?
There's a restriction on the second.
Okay, the 3 has a second restriction, so I can smush the 4 and 5, can't touch the 3. How many 4s or 5s?
2.
After that? Okay, so only 2 cases for this one. So I'm just going to simplify up these numbers. FCP says we multiply, so 2 times 2 times 5 factorial. Can we make that 20 factorial? No, so it just becomes 4 times 5 factorial. We can't multiply a number with a factorial. Second case is just going to be 2 times 6 factorial, not 12 factorial. But I'm not done yet. But the question we always ask ourselves is there repetition? Yes, so now I need to divide by the repetition. I need to divide by a 3 factorial for the 2s and 2 factorial for the 3s. Okay, so with restriction and repetition, do the restriction first, then at the end divide by the repetition.
The first one's 40.
Offer 40. Patrick, what are you staring at? I can tell. That would be hard to fake.
The second one's
120 offer for the second? And what are we doing with 40 and 120? Why?
Because it's or.
Case 1 or case 2 gives us the total of. Questions? Restrictions first, repetition second. Find a friend, try example number 4. I'll give you 3 minutes or so. May take you that long to find a friend. How many blanks would you like to write for A? Thanks. 7? What's the restriction?
The first one has to be like
Start with R.
Okay, how many choices for that R?
3.
Does it matter what follows?
6 factorial.
Okay, so simplifying that, 18 factorial.
No, 3 times.
No, 3 times 6 factorial. Okay, now we have to divide by the repetition. What repeats and how often?
R. 3 times.
Can I cancel a 3 and a 3 factorial?
No.
No. Offer of 360?
A little late, but.
It's okay, it makes me happy. All 3 R's. Ooh, that was super quick.
6 times 4 factorial.
I'm going to actually smush that into 3 factorial times 4 factorial. If you put 6 times 4 factorial, that's fine. Still have the same repetition.
3 factorial.
Can I cancel a 3 factorial with a 3 factorial? Ooh. Why can I cancel here and I couldn't right there?
They're the same.
Total is? That's fine.
6 times 4 factors.
That's fine.
Oh.
How many vowels?
6 factorial. 3 times 6 factorial. 3 factorial. 360.
There's the offer. There it is. There's restrictions with repetition. Turn and talk for number 5. I want each of you, you and your new friend, to write down a word, meaning a real word in the English language, where the total number of permutations is equal to 5 factorial divided by 2 factorial. Then explain it. So turn and talk. So you each have to come up with a different one and explain it. What would you like me to highlight? What's important?
4 red, 3 green, 2 black.
Okay. 4 red, 3 green, 2 black.
How many different?
Different words. So is this a column or a row? Something identical.
If I was going to line up for a race, I would not go as a column. Because then the last one's going to be last.
They do at NASCAR, they go like that. They call
But that's because they're going around a circle.
Yeah, but they're still racing.
Yeah, but they offset them because the inner part of the track is shorter than the outer part of the track.
But they're still lining up in columns, right? Technically.
But not one right behind each other.
Yeah, don't they go like this?
But they have their own lanes, right? They're not one physically right behind each other.
Well, like, I thought Formula 1 racing.
But they all have their own lanes. They're not in the same lane behind each other. Because that wouldn't work. That would be a really bad race.
Formula 1 is big.
We'll talk about that after. That's down there. Shh. So in the real world, I think this is not a good question because the boys would be smashing the cars into each other, not lining them up. But they're the exact same car, just different colors. So one's not like a Porsche and a Mercedes, like they're all Mercedes.
All Corollas that are red, blue.
Notes. Watch for colored objects. Your brain isn't going to see this as repetition, but if the objects are identical and they're just different colors, it's repetition. Okay? You need the word identical. If it just was cars of different colors, that would not be, because we can't assume they're the same. Okay? Identify colored objects. Identical is always going to be repetition. It's an easy one to miss because it's not like you can see 2 O's or 2 3's or whatever. So how many cars does he have? What's the repetition?
4, 3, 2.
Will this keep James busy for the entire afternoon? Sorry, 1,260? Confirmed? Colored objects. That's it. We're done permutations. Yay!